LC oscillations. We assume that initially the capacitor C of the LC circuit carries a charge Q and the current I in the inductor is 0. At that time, the energy stored in the electric field of the capacitor is UE and the energy stored in the inductor UB is 0. The capacitor now begins to discharge through the inductor. The current begins to flow anti-clockwise. The charge on the capacitor decreases, but the energy in the magnetic field of the inductor increases. The energy is transferred from the capacitor to the inductor. The energy stored in the capacitor is transferred entirely to the magnetic field of the inductor. At this stage, there is maximum value of current in the inductor. Now, energy flows from the inductor back to the capacitor as the electric field builds up again. Complete transfer of energy takes place from inductor to the capacitor. This situation is just like the initial situation except that the capacitor is charged oppositely. The capacitor will begin to discharge again. The current will now flow in clockwise direction. The energy stored in the capacitor is transferred entirely to the magnetic field of the inductor. Energy now flows from the inductor back to the capacitor. The energy is continuously shuttled back and forth between the electric field in the capacitor and the magnetic field in the inductor. The process continues at a definite frequency V. If no resistance is present in LC circuit, then the LC oscillations will continue indefinitely.